today we are working, the homework is section 3-2 out of the purple book. If you do not have it or lost it, or please make sure that you are bringing it. Take a picture before you leave. Okay? 1 through 52 all. I'm going to be working on this after school with the students. If they have time to do homework, if we get to 4:15 and they are not done, then I will likely amend the homework to like maybe the odds or something like that. Got it? But it should be pretty quick because today's purpose, are you ready to work or not? Okay. The purpose of today's lesson is to figure out if something is linear or nonlinear. A linear or nonlinear function. So, lost my clicker. My clicker there? Okay, let's take a look at this. I found it. All right, so if I were to graph this story, Beta drove to work at 45 miles per hour. She pulled over at a gas station to look for her purse. Then she raced home at 60 miles per hour to find her purse. Graph her distance from home over time. All right, so if I'm here, so the purpose of today's lesson is that we are looking at whether a graph or an equation or a table, we want to know if it's a linear or nonlinear function. That means we're going to be looking at graphs, at tables, at word problems. All right, so on this graph here, we're looking at distance from home versus time. We have three things that we're going to graph here. Beta drives to work at 45 miles per hour. The second thing she does, she pulls over at a gas station for her purse. So she pulls over, right? And then the third thing she does, she then raced home at 60 miles an hour to find her purse. What would this look like on my graph? Okay, Adam. Just the first part. This part right here. How am I going to draw it? An upward diagonal line. Good. Like a positive slope. Okay, and then when she pulls over at the gas station, what's that going to look like on the graph? Okay, let's go. Aram? A straight line, which direction? Vertical, horizontal, diagonal? Horizontal. So notice time is increasing, but my distance is not increasing. Now, she has to turn around. And she was going 45 miles per hour. Okay? The other one, it's 0 miles per hour. Because she's pulled over. What's the next line going to look like, Emerson?
It's back towards the distance from home line. And it's more like horizontal.
Is it horizontal?
It's not completely horizontal.
Okay, so can you describe? We said there's horizontal, vertical, diagonal. How would you describe this?
Diagonal, but
Heading down or heading up?
heading up.
Heading up. So we are now going diagonal again, like this.
No, back towards.
Where? Diagonal back this way?
Yes.
Agree or disagree? Because this is distance from home. Like this is 10, this is 20, this is 30. Is that getting them back home?
No.
Shh, no, I'm talking to Emerson. Is that getting us back home, Emerson?
Down.
Okay, so I would have to go down. And what kind of diagonal or horizontal? Would I do a vertical? How would it be?
It'd be slightly vertical, not like diagonal.
Is it a diagonal, vertical, or horizontal? Is it diagonal, but how would I describe that? What? Steep. Because it's 60 miles per hour, it would be a much steeper line. Does that make sense? Okay, so this is just an example. Would you say that this line should be continuous or discrete? We talked about that the other day. Alfast.
I think it should be discreet because since she's driving to a place and it's not like going on forever.
To be continuous does not mean it goes on forever. What that means is that we have to look at our domain, and are we utilizing every point in between the points based on our domain? Louis, what do you think?
So I just have a question.
Who has an opinion on this? I want to stay to this. Okay, Imani.
I think it's continuous because she's driving. Just because it's time, it's not like you have to. It's not like the last one we have to pay every month. It's time, so it continues.
Yeah, every minute she's driving or time is passing, either she's driving or sitting, but time is being used the whole way through. So in this case, it would be continuous. Okay? Yes, Ford.
So one question I had about the problem before is that or not that, but it's so if it's you get paid each month, so let's say you get paid 100.
Okay, hold on. So the question is, if you get paid $1,000 a month, would it be a continuous line? Now, it depends on what your independent and dependent is. If your paycheck is your depender, then yes, it would be discrete because it only happens once a month. Unless it's like earnings per hour, it depends on how you set that up.
Yeah.
So
Technically, if you get paid $1,000 a month, isn't it always steadily going up? You're working each
well, then you're setting it up differently.
Okay.
Go on. Yes.
How come when she goes back 60 miles to her home, how come it's not going back to where the...
Because home, remember, let's say this is 0. This is home right here. 0 feet from home. This is 10 miles from home. This is 20 miles from home. So when I go home here, I'm at, what this point really means is that I'm like 20, 30, 40, 50, 60, 70. Let's say these are minutes, right? So after 80 minutes, I'm back home. I'm 0 feet from home. Does that make sense? So this is 80 minutes, and my distance from home would be 0 feet from home. I'm at home. Does that make sense?
Yes.
Okay, go. Go. Right. Okay. All right. So this is an example of a continuous line. If we look at something like this, okay, and Martha she's putting quarters in her piggy bank every day, starting on Monday except on weekends. Graph her total savings over the first 10 days. So before we do anything, her starting point after 0 days, what's her savings? 0. And after 1 day, what does she have? 25 cents. And after 2 days? And after 3 days?
75.
And after 4 days?
$1.
And after 5 days? And after on the 6th day?
125.
I hear 150, I hear 125. Why do you say 150?
Oh, because 25 times 6 is 150.
Okay, go, Lily.
I think it's 125 because she puts a quarter in during the week, but not the weekend. And since the
6th day is the weekend, so it's still going to be 125. 7th day? 8th day?
150.
Okay. Now, would this be discrete or continuous? Discrete, because only 1 quarter is going in. I'm not doing 1.5. We look to the domain to determine if it is discrete or continuous. Okay? So this would be discrete because we're not taking half of a quarter, or we're not using half a day. Remember this one on minutes to volume of gas in the tank? Would this be discrete or continuous?
Continuous.
Because my domain is continuous. I'm not just putting gas in at the 2-minute mark, the 4-minute mark. It goes from 0 to whatever till it's full. Okay? All right. I'm going to move forward. So let's continue. Now, another way we look at equations, and the way we tell is when x is to the first power, it's going to be a linear equation. So y equals 3x is linear, where y equals 3x squared is not. By the way, can you show me with your finger what x squared looks like on the graph? Y equals x squared. What shape does it make? Gideon, what shape? What's it called? A parabola. Everybody say parabola. So, anything x squared makes a parabola. Is not a line. When they say, is it a linear function? If it looks like a line, it's a line. Okay? And in the equation, x really has to be to the first power. If it's any other power, then it's not going to be linear. Now, this is the same basically as y equals 1/2 x minus 1. So, is this a linear function? Yeah, x is to the first power, so it is. Okay, you should be writing these. Samples of linear versus nonlinear. Y equals x to the 4th. It has an exponent, so it's not a linear function. What about this one? This is the linear function. It starts at the y-intercept at 5, has a really steep slope because x is to the first power. But the square root of x is not a linear function. Okay? This on our graph looks something like this. Okay? Next one. If we have circumference is a linear function because what's changing diameter is to the first power. But area of a circle is not a linear function. It's a function, just not a linear function. And that's because the radius is squared. Perimeter of a square is linear, but area of a square is not. Because side squared is not. S is to the second power. If I add x and y in my function, you should be writing this. Write notes. Thank you. Okay, to get y alone, what would you do?
Subtract x.
So y equals negative x plus 7. X is still the first power. But when I multiply x and y together, let's get y alone. What would I have to do? By x. And we get y equals 7 over x. Do you guys remember what that looks like on the graph? When x is in the denominator, and I said, please don't get lazy because you will get something like this. Do you see those two lines? Okay. So when x is, it is not linear. Huh?
Ski jump.
Yes, ski jump. Right. All right, so now let's look at some homework problems. Is y equals 3.8 a linear function?
Yes.
Yes, it's a horizontal line. What about y equals the square root of x? No. What about y equals 3 to the x power? No. This is what we would call an exponential function. It starts out really low, and then it gets big really quick. Okay, what about the next one? Y equals 6 times the quantity of x minus 1.
Yes.
Function. What about the last one?
No.
Right, and if once you get y alone, you get negative y equals negative x squared. Divide both sides by negative 1. We still get y equals x squared. X is not to the first power, so it's not a function. Looking at the graph, is a linear function? No, it's a function, but not a linear function. There's no line. Okay, B, is it a function?
Yes.
Yes. Okay? Yeah, I shouldn't say is it a function. Is it a linear function?
Yes.
Yes. Because it has a line. Okay, A. Is this a linear function? No. And B? Yes. Okay, question, Amani. Let me clarify. To be a function, x should be usually is to the first power. It should not be in the denominator. And if you're multiplying x and y together, when you get the y alone, that will put x into the denominator. So that wouldn't be a function either. And we don't want to take the square root, okay, or even x to the power. When we have a table, what we're going to look for, now your table might look like this, or it might look like this. Okay? When we look at the table, what we're looking for is a constant rate of change. Your change in y over your change in x is your slope. Is this a constant rate of change?
Yes.
Adding 6, no, subtracting 6, minus 6, minus 6, minus 6. And this is add 3, add 3, add 3. So yes, now, it's a linear function because it has a constant rate of change here and here. So if I wanted to find the actual slope, I would say negative 6 over 3. So it would be negative 2. What about the next one? Take a minute and you guys do it. Go. Go. Tell me if it's if it's a linear function. Pause the recording. So let's check and see. We can see on part B, we're adding 2 every time. That's the rate of change. And down below, what am I adding from 2 to 9? Plus 7 here. Plus, is this a constant rate of change? Is it the same every time? So it is a non-linear function. Does that make sense? Okay, so can I erase? Yeah.
It is, like, it's not constant, but you can...
It has to be a constant. I didn't ask if it was a pattern. I asked if it's a constant rate of change. The change has to be the same in the numerator and in the denominator. Not the same as each other, but it just has to be the same from each y. All right, letter A. Is this a linear function or nonlinear? Linear for up, nonlinear down. Let me see thumbs in front of you. Linear, nonlinear. Okay, Megan, what is it? Linear function. This one's increasing by 2. This increases by 2. Right? And this is increasing by 9 each time. Letter B. Is it a function or not a function? Riley, what do you say? Why?
Because the first one you're adding 2, and then the second one you're adding 27, and you're adding 90.
You mean for the range, I'm adding by 27, and then I'm adding by 98. So it's not a function. Not a linear function. Sorry, not a linear function. It could be a function. It's just not a linear function. All right, we went through these. Let's look at a word problem. A cereal bar contains 130 calories. The number of C calories consumed is a function of B bars eaten. So what is the depender? Calories or bars? Calories is equal to what? Equals, and how much per bar? 130 per bar. So, is this a linear function? Yes. It's going to have, let's make a quick table. So, bars to calories. So, Sam, for 1 bar, what's the calories? Good. For 2 bars, Sam? Good. 3 bars. 390. Okay? So, does the situation represent a linear function? Yes, because as each bite I take, Would this be discrete or continuous?
This would be continuous.
Yeah, because if I eat one bar and a bite, one bar and 2 bites, one bar and a bite and a nibble, that's always adding calories on. Find the domain. So my domain is my B. So tell me about the domain. It has to be greater than what? 0. Because I could take just a nibble. I don't want to start at 1.
Greater than or equal to 1.
It has to be greater than 0. Because I could take 1 nibble. And that's going to add calories to me. My range is going to be what? Let's see. Find the domain. Is the domain discrete or continuous? We decided it was continuous. Because all those bites. Then to graph it, once you have that table, we can plot those points. Okay, questions? One more slide I want to show you. One more slide I want to show you. Okay, write a real life situation to fit the data shown in the graph. Is the domain of each function discrete or continuous? A, is it discrete or continuous? Discrete. So now let's look at a real life situation. And they just took this and then they one possibility would be 2 people bidding on each other for 6 coins. So what this point represents is if, let's call this guy A and this guy B, if person A has 6 coins, then B gets 0. Or this means if person A gets 5 coins, then person B gets 1. With this, do you see how you wouldn't have a half a coin?
Yeah.
Okay, now look at the other one. The other one would be, because the domain is discrete here, you can't take a half a coin. Look at this one. One possibility for the continuous domain would be people bidding on each other for 6 ounces of gold dust at an auction. So all the dust will be purchased by 2 people. Because it's possible to purchase any portion of the dust, then we would use the continuous one. Does that make sense?
Yeah.
All right, that's an example of a real life. All right, wow, that was a lot of me out of breath. And that is our lesson for the day.